Types of retaining walls. What is a retaining wall? A retaining wall is any constructed wall that holds back soil, a liquid or other materials, where there is an abrupt change in elevation. A retaining wall is subjected to both shear and bending stresses in the stem and base caused by the lateral pressures induced from the soil that it is supporting. Retaining walls are found across a wide variety of contexts, from basements to highways and rail, to ports, and can vary in their design to suit the context. Figure. There are various types of retaining wall structures which are used for numerous goals. Types of retaining walls. 1. Gravity retaining wall. Gravity retaining wall depends on its self-weight only to resist lateral earth pressure. Commonly, gravity retaining wall is massive because it requires significant gravity load to counteract soil pressure. Sliding, overturning, and bearing forces shall be taken into consideration while this type of retaining wall structure is designed. It can be constructed from different materials such as concrete, stone, and masonry units. It is economical for a height up to 3 m. Crib retaining wall, gabions, and ben retaining wall are also type of gravity retaining walls. 2. Crib retaining wall. Crib retaining walls are a form of gravity wall. They are constructed of interlocking individual boxes made from timber or precast concrete. Then, the boxes are filled with crushed stone or other coarse granular materials to create a free-draining structure. Basic types of crib retaining walls include reinforced precast and timber retaining walls. It is suited to support planter areas, but it is not recommended for support of slopes or structures. 3. Gabion retaining walls. Gabion retaining walls are multi-celled, rectangular wire mesh boxes, which are filled with rocks or other suitable materials. It is employed for construction of erosion control structures. It is also used to stabilize steep slopes. 4. Cantilever retaining wall. Cantilevered retaining walls are the most common type and are commonly masonry or concrete in construction. This wall has a vertical, or inclined stem monolithic with a base slab, and is suitable for heights up to about 7 m. Its slenderness is possible as the tensile stresses within its stem and base are resisted by steel reinforcement. If the face of the wall is to be exposed, then general practice is to provide it with a small backward batter of about 150 in order to compensate for any slight forward tilting of the wall. Typical dimensions for the wall are given in Figure 2. A mass construction gravity wall can take such stresses in its stride, but this is not so for the vertical stem of a reinforced concrete retaining wall. If structural failure of the stem is to be avoided, then it must be provided with enough steel reinforcement to resist the bending moment, and to have a sufficient thickness to withstand the shear stresses through the section to its height. It is in this situation that a limitation on the practical height of the wall stem of 7 m is imposed for a conventional retaining wall. As the dimensions of a wall increase, it becomes less flexible and the lateral pressures exerted on it by the soil tend to be higher than the active values assumed in the design. 5. Counterfort/buttressed retaining wall. Counterfort cantilevered retaining walls, Figure 2, incorporate wing walls projecting from the heel into the stem. The stem between counterfort, wing walls, is thinner and spans horizontally between the counterfort walls. The counterforts act as cantilevered elements and are structurally efficient because the counterforts are tapered down to a wider, deeper, base where moments are higher. The high cost and increased complexity of forming the counterforts and infill stem walls make such walls less practical and desirable unless the situational complexity requires it. Counterfort spacing is equal or slightly larger than half of the counterfort height. Counterfort wall height ranges from 8-12 m. 6. Anchored retaining wall. This type of retaining wall is employed when the space is limited or thin retaining wall is required. Anchored retaining wall is suitable for loose soil over rocks. Considerably high retaining wall can be constructed using this type of retaining wall structure system. Deep cable rods or wires are driven deep sideways into the earth, then the ends are filled with concrete to provide anchor. Anchors, tiebacks, acts against overturning and sliding pressure. 7. Piled retaining wall. Pile retaining wall are constructed by driving reinforced concrete piles adjacent to each other as shown in the Fig 15 and 16. Piles are forced into a depth that is sufficient to counter the force which tries to push over the wall. It is employed in both temporary and permanent works. Piled walls offer high stiffness retaining elements which are able to hold lateral pressure in large excavation depths with almost no disturbance to surrounding structures or properties. Sheet pile walls are built using steel sheets into a slope or excavations up to a required depth, but it cannot withstand very high pressure. Sheet pile retaining wall economical till height of 6 m. 8 mechanically stabilized earth, MSE, retaining wall. It is among the most economical and most commonly constructed retaining walls. Mechanically stabilized earth retaining wall is supported by selected fills, granular, and held together by reinforcements, which can be either metallic strips or plastic meshes. Types of MSE retaining wall include panel, concrete block, and temporary earth retaining walls. 9 hybrid systems. Retaining walls that use both mass and reinforcement for stability are termed as hybrid or composite retaining wall systems.